All right, so we've been talking about solving exponential equations, and now we're going to talk about solving logarithmic equations. And if you remember, logs and exponents are inverses of each other, so the properties and the ways we solve them are going to be very similar. So for logarithms, we have a one-to-one property of logarithmic functions, and it's just like the one-to-one property for exponentials. The key is we have to have the bases the same. So if we have log base b of x equal to log base b of y, then x equals y. And notice that the key here, just like with the exponents, is that we have the same base. So a quick example of that would be if we see log x equals log 3. Well, we know, even though we don't write it, that this is log base 10, and this is log base 10. So since our bases are the same, we can say that x equals 3 because that's all it could equal. X and 3 are the only things different in these two sides of this equation. All right, so we'll move down to a little example. We have a log of 2x equals log of x plus 4. Again, these are base 10, so the bases are the same. So 2x equals x plus 4. Then we just solve these like an algebra 1 problem. So we get x equals 4. Nothing to it, right? So here we have the natural log of x squared minus the natural log of 36 equals 0. With logs on the same side, there's not a lot we can do. So we're going to put the natural log of 36 over on the other side. So now we have natural log x squared equals natural log 36. Okay, both of these are log base e. If you remember, ln is log base e. So these have the same base. So x squared equals 36. So you know that x equals plus or minus 6 because we square root both sides, and that's it. So our strategies are similar to the exponents. First one is that we're going to rewrite the original equation in a form that allows us to use the one-to-one function. I should say one-to-one property of logarithmic, and cross that out. I should say equations. Our second strategy is that we can use log properties for condensing, like when we have two things that are added and we combine them together into one log with multiplication, or when they're subtracted and we combine them with dividing, and then use the one-to-one or the inverse properties. And our third step is we rewrite a logarithmic equation into exponential form and apply the inverse of exponential functions. So take a look at what that looks like. So we have this ln x equals 6, right? So the natural log of x equals 6. And remember, you have to isolate the logarithms before we do anything. So in this one, we don't have a problem really, but in the next one, you'll see that we do have a problem. So the natural log of x, well, that is log base e of x equals 6. Okay, natural log and log base e mean the same exact thing. Natural log is just the way that we write it. So now that we've written this, hopefully you guys remember that this is the base. Okay, this is the exponent, and the x is what it equals. So we're going to have e to the 6th equals x. And you might say, well, we still got two letters. This didn't help me out very much, but there's an e button on your calculator. E is a number, so this is really some number to the 6th power. So you type e to the 6th into your calculator, and you get that x equals 403.43. All right, so move over here. We're going to try this one. Now, remember, we want to isolate the log, so we want it to just be log 5x and nothing else. So first step, subtract 6. So now we've got 2 log of 5x equals 4. Then we're going to divide by 2. So now we've got log of 5x equals 2. Well, you know that this is log base 10, right? Even though we don't write the 10. So this is 10 squared equals 5x. So 100 equals 5x. So divide both sides by 5, x equals 20. So now we're just going to do a few practice problems, and hopefully you'll see that solving logarithmic equations is really not that tough. So here we have log base 3 of x squared minus 1 equals 4. And that might look pretty complicated, but you just have to remember this is the base, this is the exponent. So 3 to the 4th equals x squared minus 1. Well, 3 to the 4th is 81. And that equals x squared minus 1. So we add 1 to both sides. So we're going to get 82 equals x squared. And solve this, we'll take the square root of both sides, and we're going to get that x is approximately plus or minus 9.06. Alright, so here we have an example with several logs in it, but luckily they're all base 4, so we just need to do a little simplifying or condensing, and this will be nice and simple. So log base 4 of x. Now over here we have log base 4 of 3 plus log base 4 of x minus 2. So we're going to write that all as one log, so it's log base 4 of 3 times x minus 2. Remember, because they were added, we can combine them into a single log with multiplication. So now we have the same base, right? 4 and 4. So x equals 3x minus 6. I just distribute this 3. So now I'm going to subtract 3x. Get negative 2x equals negative 6. Divide by negative 2. And I get x equals 3. It's not so bad. Alright, got another one down here. Everything's 12, base 12, so we've got an addition in between, so we're going to combine these two together using multiplication. So we get log 12 of x plus 3 equals log base 12 of 4x. Just take the x and the 4 and multiply them together. So now we've got two logs, same base, so x plus 3 equals 4x. Subtract x from both sides. 3 equals 3x. Divide by 3. X equals 1. Alright, the last thing we're going to go over is something called a change of base formula, which is not new. It's something I showed you a long time ago to make this just easier for you. And all it says is that if you have log base b of a, that is equal to the log of a divided by the log of b. But what you didn't know is that's also equal to the natural log of a divided by the natural log of b. So sometimes you can use logs or natural logs depending on what's more convenient. So if we look at this log base 3 of 5, use a change of base formula to find it. You just do log 5 divided by log 3, write in your calculator, and that's going to equal 1.46. Okay, over here we have log of 2/3. I'm sorry. We have log base 2/3 of 8. So that's going to be log 8 divided by log of 2/3. Type that right in the calculator. Negative 5.13. All right, last one says rewrite the following in terms of natural log and common log. Well, common log is base 10, and natural log is your ln. So log base 8 of 17 equals log base 10 of 17 over log base 8, which is what we've been doing all this time. But that's also equal to the natural log of 17 over the natural log of 8. So nothing new, just another way to hear it. So change of base, that means exactly what we've been doing. All right, so good luck, and I will see you guys tomorrow.